Okay, I seem to be live, and welcome back. I'm John Ball, the CTO and founder of Pat Inc. And today I'm going to talk about the new NLU Industry. And I'm also going to turn that off so that you don't hear me say everything twice. Okay, so what is the next big IT industry? It's going to be a natural language understanding driven industry in which machines understand what we're saying, and as a result we're going to be conversing with them in either our normal speech with voice, or we'll be typing as we do today with other types of platforms. So let me just give you a quick warm-up as to what the NLU industry is going to look like. So we'll have a look at this one. So here's the Commonwealth Bank. Let me just drop that off. One of the top 10 banks in the world, so a very well-known brand. And as we go through here, what I want to do is access their chatbot. So we can go here and we can message them with the virtual assistant. Oh, and now I've got to go onto the CommBank app. It used to be that I could access this directly from the home page, but I have actually checked this just before the call, and I'm going to take you through what the interaction was in order to find out information about my bank details, or about a loan in that case. So let's go from what the chatbot currently does for a very major corporation, and we'll have a look at another large corporation, the round the world environment. So here I've gone to the One World environment. This is the system that Pat designed back in 2020. We're going to go into the virtual assistant that's in beta, and what I'm showing here is how the use of NLU, of understanding language and understanding how conversation works, is beneficial for us to make chatbots work better, to make virtual assistants work the way people do. So let's just skip through the preamble here. So notice that it asks me a question: from what city would you like to depart? And the reason it's doing that is once you as the system ask a question, the person's forced into this concept of narrow focus. They're answering that question. And as long as they answer it, that really constrains what the question, what the interpretation is going to be. So let's just put in here, say, the Windy City. Let's just try and have a bit of fun here. So I'd like to go from the Windy City. And where is that? Well, if you're from Chicago, you'll know. And it says here, I've set your home city to Chicago. It's given us the pricing. And remember, that was one of the goals of the next generation technology. In order to very quickly find out important information like what the price is, so that you don't spend half an hour trying to organize to book something and then find out, hey, this isn't going to work. It's not in my budget. So let's stop showing tips. Now, what cities would we like to visit? Notice again, the first question was narrow focus. The second question is narrow focus. So if I put in 3 different cities, we'll say Tokyo, in no particular order. We'll say New York, and we'll say Sydney, where my accent comes from, or part of my accent anyway. And at this point, you can see the system's going away. So the point of that is the next generation NLU is going to be exploiting how we talk to each other, and as a result, the system's going to be much easier to use. You can contrast that to what you'll see in the Commonwealth Bank example, where it's asking these very general questions and then slowly narrowing down. Now, in the case of RTW, it's a very narrow use case anyway. We're talking about round-the-world systems, so it's not going to ask you whether you'd like a loan or if you've got a problem with your credit card. And so here, it said, I assume you mean Sydney, Australia. Another option would be Sydney, Canada, wherever that is. And then it's added Tokyo, New York, and Sydney to the itinerary. And now we've got to add another stop in Europe or something. So I'll just say London, just to see whether or not we can get the RTW validation done. Okay, so we've added London, and yeah, so now we can start to set city order. I'm just going to press it and you can see it's worked out that you can go Sydney, Tokyo, London, New York, Chicago. So starting in Chicago, that's the order that you finish up with. Now, it's not really a big claim to say there's a massive application for NLU. The challenge has been since the 60s, people have wanted to do this stuff, but it hasn't worked. And one of the reasons it hasn't worked is because the science hasn't been ready to understand human language. And the models that we had in the 60s, 70s, and 80s were all these rules-based models that used an old style of linguistics. And we've been able to recover from a lot of those issues by simply iterating around the scientific model. And for example, error correction. This is something that, if you know about parsing, is very hard to do because it doesn't really follow the parsing model. You have to build some very strange rules. And as far as I can tell, you can't solve those rules unless you know what is actually meant by the words. So let's look at an example here. So here's predicate replacement. So here's some errors. Can you glimpse, no, see the dog? What would that mean? Probably means, can you see the dog? So here's a different style of correction. Can you be glimpsing, no, seeing the dog? To me, that would mean, can you be seeing the dog? If we select that, you can see you seeing progressive, so be seeing, and the dog. So you see the dog is the meaning of that. And then we can see here that there's a question involved because can you be? So there's so much information in these English sentences that we can get these answers. But notice here, if we now use this in conversation, so here's getting back to what the chatbot's looking to do. We're trying to get the conversation to work. So when I run all of these in sequence, you can firstly see the performance of the system, and secondly, you can see what the answers are. So John has no is being glimpsed, no seen by the dog. So that means John is being seen by the dog. Okay. Who is glimpsed? I don't know because we corrected it. John is seen. Who is seen? John is. Who is seen? John is. So different ways of asking the same thing. Who did the dog see? John. So that's one example of error correction, which is an previously unsolved problem with NLU. Let's just look at one other example. When we're talking about when and where, we'll often use a very complicated expression to position that. We don't always say I want to go tomorrow or I want to go in a week. We might say something like one of these examples. So here's one. The girls were eating when the soldiers were marched by the sergeant. So that's probably not the first choice that you come up with for a sentence, but what this is saying is the girls were eating. So there's our progressive girls were eating, and I've been warned, thank you, Rolly, about the moving my cursor around too much. And then when the soldiers were marched by the sergeant. So there's another sentence embedded in that. And if we click down to the details, we can see when was it? It was the sergeant marched the soldiers. So if you know when the sergeant marched the soldiers and you take the time out of that, you're then able to answer the whole expression. So there's my introduction. So there's new technology that enables NLU to work. There's the new approach to next generation virtual assistants, in which the system is asking you the questions and then you're able to answer the questions. And as I've talked about previously, the agent that we're talking to there isn't just asking you questions out of random, for random reasons. It's asking you those questions because it knows what user requirements it needs to talk to the IT system to get the correct answers for solving your problem. In that case, RTW, but in other cases could be something else. Okay, so let's go back to our presentation here. So the new NLU, what are we going to talk about today? Well, firstly, let's have a look at what the Commonwealth Bank interaction was. So if we think of IT systems on the web as initially being those nice drop-down menus where you select things, I guess that came from the Windows environment. The second generation of virtual assistants that came about from 2012, when the big deep learning push took over and we were looking for chatbot technology to replace everything. That was about 10 years ago, and it hasn't. So here we've got, hi John, welcome to messaging. So this is Chiba, whatever, however you pronounce that, the Commonwealth Bank system. I'm your virtual assistant. I can get you instant answers or connect you to the right specialist. How can I help? So I've said, can I get a home loan? Sounds good. Comes back very conversationally. Sure, I can help you with home loans. Select which type. And now we've got, there was a bunch of choices. I selected new loan inquiry. So it was a click bot instantly, which is pretty much, if there was a button at the top that said home loans and it had a drop down, I've just clicked on new home loan. So it's using exactly the same old technology that we had in that style of environment. And then the next question, what do you want to know about? Loan offers, loan application, interest rates. I think I said interest rates. Yes, I did. And then it comes up and it allows me to click on a button that takes me to the home loans page, which is a web page. So if you look at the old technology, you'd have a pull down, you'd click on something, it would take you to a web page. Now you go through this virtual agent chatbot, you're clicking on things just like the menu, and then you finally click on something that takes you to a web page. So it's not even conversationally taking you through the details of the home loan or the interest rates in that case. And then at the end here, you can see that it's checked whether I was helped with that inquiry. Fantastic. So we can do a lot better than that, and that's what the next generation NLU promises. So today we're going to talk about what the new NLU is, which I've already started to introduce. The reason comes back to if we can split the workload from user requirements to IT requirements, we can then interact with user requirements in our own language. So rather than the IT requirement being give me the date and time that you want to leave, and you're scratching your head, I want to go tomorrow. Well, what's tomorrow? Let's see. Looking at my calendar here, it's the 24th of the 10th, 2022. So that's the 25th of the 10th, 2022. And then if I don't have to translate into some other time zone, I can tell you, what time. So that's a lot harder than just saying tomorrow. And then Gary Marcus is one of the heavy hitters in this industry, in the AI industry. And his claim to fame is simply looking at what we've already learned that doesn't work with AI for the reasons that we've covered over the last 60 years, if not longer. And then he says, here's the things that you need to be able to do. And then he tests the latest systems and says, hey, it doesn't do this. So that is a virtuous circle where we're getting the correct information about what we need to do to solve the problems. Now, sometimes it's looked upon dimly because when he's saying you just have to change this, it could be an unsolvable problem with the current paradigm. And people don't like finding that they've just hit a wall, as the expression goes. And then engineering approach. So I've shown you a little bit about what we can do, but obviously to build an industry around new technology, it's more than just, hey, I've got this capability, go and do something with it. So we'll go through that. And we'll show how we're integrating linguists with computer scientists and cognitive scientists in order to produce a repeatable, trustworthy source for natural language understanding. Okay, so what is the new NLU? Well, I think I've gone through these points. So we're going to exploit natural language, and I'll just make sure I haven't missed any points here. We're going to focus on goal direction, like RTW. And goal direction is the other way of putting it, where the agent has got some goal and the agent is pushing you to get to that solution. And it's very powerful as long as you can deal with the responses that the person comes back to you with. We need to improve technologies. So in order to deploy this, where we want to go with the new NLU is to take all of the published information, websites, magazines, newspapers, in any type of communications, and rather than store it as a text file, we want to store it as a meaning-based file. So this leads into the work that I talk about with the super knowledge graph, which is a lossless form of the language that you've entered. And then by taking that meaning representation and generating it into whichever target language you like, because in theory, with the role and reference grammar linguistic theory, you can then generate into any language you like, simply by identifying the correct phrases and therefore the words that produce the same meaning. that's our goal. But you don't start with that. You're going to start with things like RTW, where you're producing useful tools for people where they're getting their tickets faster. They're getting their tickets at all. In the case of RTW, I could spend an hour and not get a ticket because I just get lost with the complexity of geography and limitations of the ticket rules. So that's what the new NLU is. How can we scale it? I've got to say that since I've been doing this work full time since 2006, the first question I always get asked, in a very strange way, I've got to be honest, is it won't scale, or how can you scale it? And I've always wondered what that means. And I guess if you were an expert in the technologies that have been coming out of Silicon Valley since the late 1950s, these NLU systems would always get to a certain point and then fall over. The more information you'd put in, the more complex and difficult it was to administer, and then we still weren't getting the right answers out the other end. And I guess that's why rules-based systems today still have such a bad feeling about them. But if you don't keep iterating on the science, you're going to be caught with unsolvable problems. And the starting point for all of that revolution in linguistics back in the 50s is still in place today. Nowadays, rather than worrying about how to solve the actual problems caused by those formal models, we worry about how we can implement that bad model on new technology. And so by getting the science right, we can then produce systems that scale. So here, if I look behind my head, let me see what that. Okay, so we've got our user here, and the user talks to a virtual agent. And a couple of terms, I'm just going to throw them out there. Immediate common ground or context of utterance. When we're talking to somebody, we have to understand what's going on at that point in time. Otherwise, it's not a human conversation. And then on top of that, you've got the background knowledge. So, when I say Barack Obama, that sound, for most people, is going to link to the President of the United States from whenever it was, 2008 to 2016. I'm more a programmer now than a mathematician, so not that good with the numbers in my head. So the reason it scales is, firstly, this virtual agent model using super knowledge graphs is making the problem much smaller, because you're focusing on how you can get user requirements. And then secondly, in terms of the science, by removing parts of speech, you no longer have the unsolvable combinatorial explosion in parsing. The number of predicate classes through our early analysis is maybe 250, maybe more like 25. It's a combinatorial system where once we've got the elements to define predicates, so that's what used to be called verbs, adjectives, adverbs, and prepositions. So those things that relate other objects in a language. 25, 250, even if it was 1,000, that's not a very big number for us to manage. And as I've shown previously, some of those classes might have 1,000 tests that you have to do, but we can do tests. I'll show you what the process is for that too in a moment. The other thing we talked about is 50% of the words that we use in language. So if you look at a billion word corpus, 50% of those words are the first 66 words of English. And they're words like the, and, a, and. Those are the words that we use to understand the context of what we're talking about. So that's not that hard to implement if you have a context engine that works. And then secondly, the next 2,000 to 4,000 words is covering about 80% of language. And people would say, well, that's right, but if you only have 80% of language, you don't understand anything, because that's one parole wrong in each sentence. And parole is another meaning of word. I'll give you my parole, my word in war. So if you didn't understand that sentence, that's the problem with getting one parole wrong in 5, 80% hit rate. So when you do the next level of analysis, you realize that on top of those 4,000 words, which is good enough to get by in any language in the world, because you're able to point at things and use the rest of your capabilities to understand what it is that you're trying to get, and with the language that you've got, you can say, I want that, and you can point at a hot dog or a Coke or whatever it is you're trying to get. Now, as you develop more vocabulary, what are those extra words? And that's the very large side of language. Named entity recognition is the technical term that people have used in recent years. I call them special reference. So once you get into people's names, there's more than 1 billion people on the planet. So there's more than 1 billion names. Company names, there's a lot of those. Street names, country names, animal names. Once you get into all of those specific examples, of which they all underlying them would be person, company, street. If you understand what street and person and company are, you could just use those words, and the person that you're talking to can play 20 questions and try and get what you want. So the reason NLU can be scaled is because we've broken down the science correctly so that none of those problems are unsolvable. Is it important to, for example, talk about interleukin 33 when you're on the RTW website? Interleukin 33 is a very important concept in medicine, but no, you can get away with not knowing about certain things in order to solve other problems. So the infiniteness of the potential words that we might have to deal with, because I should mention too, it's not only the current people that have names. Everybody in the past that's died has also had names, and potentially we need to refer to them as well, and their stories. So our world is complicated, but if you have the right science to model that, then who cares that it's complicated? You just implement it. Okay, so what is our next generation AI? This is now going over what I've talked about earlier, but it's good to make the point just to make it really clear what we're trying to do. I'm just checking if there's any questions from the group. I don't see anything here. Oh, comments. Let's see what we got. Okay. No comments at the moment, so we'll continue on. And now I know where the comments are. Great. Okay, so the first stage of the next generation AI puts a virtual agent in the middle, and this isn't the open domain agent. Oh, you'll have questions in a minute. Good. The virtual agent sits in the middle, and what they care about is your requirements. If you think about that airline ticket example, when you're sitting in the middle of that service as the travel agent, you don't know all of the plane flights that exist in the world, when they're leaving Tokyo, when they're arriving, what the rules are around that. There's a system that knows that. So what you're asking the customer is, what are your requirements? When do you want to go? And not surprisingly, people don't normally know the date and time of every single thing that they're going to do in their life. So they use normal language like, I want to go in February, for example. I want to go for 2 months, for example. And that's enough user requirement to get the system to then go and do the hard work of, well, if I start on this date and I try that, is that possible to then continue my travels? And the system can then do all of that hard work of doing the transactions to the IT system, while the travel agent and the end user can just sit around waiting for that to respond. And you can see in the RTW case, the back-end system is so much faster than a person. Things that a person might take a week to do by constantly trying, well, let me try the next day, let me try the next day, let me try the next day, and having no flights, that can all be done at the speed of IT. So it's much better. So here in my diagram, you can see that the person talking to the bot says, I want to go next week, and then the bot can convert that to the 1st of the 11th, 2022 to the 7th of the 11th, 2022. And in that interface, the system can know that we're talking about the 11th month, November, so the 1st to the 7th, rather than the American approach of 11/1/2022. And so there's our little back-end system happily going and doing all the hard work. Okay, so back to Gary Marcus. I think his company is Robust AI, and he talks about robust AI being AI that you can trust. So the analogy I like to use is when we go to a calculator from the 70s and you type in 7 times 10, you get 70. You don't get 69.9999999. You get 70 because that's what the system's supposed to do. When you go to a chatbot today and you say, can you get me information about my bank details? It will often come back with, hi, what can I do to help you? Or I didn't quite get that. And that's not AI you can trust. So a couple of things that we have to do comes from the focus Gary has on solving the problem of AI. Reliability and repeatability. So when you look at the round the world ticketing system, I know I'm harping on it, but that's our first big design that's now out in the wild. What you see is that the language that goes in, I want New York, isn't just off into a vacuum and then you go, oh, don't know what happened there. You then see New York drawn on the map. You then see New York on the itinerary in some sort of sequence. And as you're going through, the system is constantly showing you stuff. So it's as if the travel agent's saying, how does this look? So in a normal interaction between people, you'd go to the travel agent, you say, I want this, and then they'd have an itinerary for you with the price, and they'd say, how does this look? And you go, oh, can you change Paris for London? Swap the order. And they go, sure. And then how does this look? So that type of feedback, that's implementing Gary's concept of robustness, reliability, and repeatability. So as long as you're meeting that level, even if your system's not perfect, you say, I want to go next week, and it says, oh, you want to go in 2025? No, next week. Next week. Then people will have confidence in your system. Okay, next point. Pat's next generation AI requires multilingual confirmation. How does this look? Oh, multilingual. No, it's not multilingual. It's multimodal confirmation. Now, but thanks for putting that point in. It requires multilingual confirmation as well. So once a company has built one of these systems, and let's say they spent a couple of $1 million building it, they don't want to be caught with then deploying it to Paris, to France, and then having to rebuild the entire system from scratch in French, basically taking all of the phrases that have already been defined for the first NLU system to do for French, and then do it for German, and then do it for Italian, and then do it for Mandarin, and do it. So yeah, I could go on. But the point is that if you're storing by meaning and generating into target languages, you've just reduced the cost dramatically because that localization function is very expensive. Let me just, do we have any questions at this point? How do you train Pat on language for my use case? Yeah, so that's a good question. So in order to make that work for the airline system, we did a fair bit of analysis over a 6-month period looking at how to make this thing work, and we came up with the agent model and the design features that you see. But the concept of training is the one that relates to machine learning. So if you're a machine learning implementation, you have to get a lot of data that you can then convert into whatever it is, a neural network or a statistical system that produces your answers. And that's training. But in our case, if you were to put in the facts that you know at this point in time in the language of your choice, so you put in your flight's going to leave on this particular date, that information can then answer questions. So if the person says, when is my flight going to leave, you take the date out from your context and then you present that. So the concept of training disappears. And the good news is that training and the annotations that are one of the big cost drivers in the AI field can disappear and be replaced with this system, which, when you think of it, once the system's got the English sorted out, it doesn't change that much. You can keep refining it, of course, but the training problem disappears. The other thing about the machine learning paradigm, and deep learning for that matter, is it's not testable. So once you've built your system, once you've trained it, and it's producing answers, well, okay, you can test it manually, but can you test everything? Well, you can't. You'd need tens of thousands of tests, and if you change your training, change your data to get something else to work, potentially all your tests are going to fail again. And so that virtuous circle, I've got to get that right by the end of this, that virtuous circle is failing. So with the machine learning paradigm, because you can't test data. In our case, we're testing a scientific model that we've implemented, and so it does pass. And so testing becomes a key driver of this type of IT system with the next generation NLU. Okay, another question here. Are there differences between languages that require special treatment? How do you handle those differences, for example? When we were experimenting with RRG, so going back to 2012, 2013, when we got the first conversations working, we also wanted to make sure that it would apply to many languages. So we looked at 9, and we made sure that they were, like RRG recommends, 9 quite different languages. Japanese was one. We also looked at Spanish, Korean, Mandarin, Indonesian. Indonesian has different types of pronoun use. So the challenge of those languages will be Pat's problem or will be the NLU company's problem, because you just need a generator into that language and a recognizer from that language into the meaning repository. So if you do each language once for each of the world's languages, you finish up with this nice interaction to the meaning repository, and the cost is therefore very much shared. Once you've got your English recognizer and generator tested, it's not going to change very much, and everybody on the planet that wants to use English can use that one. So we think there's a big cost benefit by using that model. What's in it? So there's a dictionary and encyclopedia but both of those you want to test. The dictionary you think of as the words and phrases in a particular language, and the encyclopedia is the super knowledge graph, the meaning repository, which is also unchanged for the world's languages. Regression tests, so we're very much in this model of we make changes to our system. Often that means we add new words that are the same as other words with different meanings. For example, thanks Rolly for this, you put in a new name for somebody which was happy, and we had some tests fail because happy is normally the predicate that's about being happy, and in this case it was a girl's name. So we had a couple of things that we needed to tidy up, but because we have 7,000-8,000 tests that we run before we release anything, once we had all those tests passing, we were then confident that the system was going to continue to perform for users as it did before. So that's robust AI, and that's how we can get trust. Engineering follows science. I did a program last night looking at one of the new scientific approaches. So at Facebook or Meta, Jan LeCun is talking about the things that he wants to do in order to get AI to progress. And when you look at his discussion paper, the second point was the system has to align with gradient descent. And okay, that basically means that you're forcing into your scientific model an engineered solution, which is the deep learning paradigm. And the problem with requiring your science to follow engineering is you're putting the cart behind the horse, cart in front of the horse. If you put it behind, that's probably normal. And that's not good. So what type of engineering are we using? Well, role and reference grammar. So that's the linguistic framework that Robert D. Van Velen Jr. has been developing since 1970s, certainly the 1980s when he released his 1984 book with Bill Foley. Pattern theory, about 2000 was when I finished development on it, and it seemed like a pretty good paradigm. It's the paradigm where all of your body's sensors and skin is connected to a brain, and then the brain is controlling the body through muscles. And so that paradigm of how we put that together basically means that memory is distributed in the senses and associated together, which I think a lot of people find quite intuitive. And when you look at the problems that solves, it's much better than the computational model, where I don't think anybody's come up with a way of, for example, storing the contents of a meeting without writing databases and doing some hard stuff. So that was that's a mature science. Semantics theory. Sebastian Loebner's semanticist from Heinrich Heine University. That was about 2004 was his well-known book on semantics, and he's got a couple of releases since then. Semiotics. So how do languages work? You've got signs that connect to interpretants that represent objects. So the interpretants can be, like in a dictionary, multiples. So the sign connects to multiple interpretants, and then you have to work out, based on the context, what you're referring to. So thanks to Mr. Peirce for that. WordNet, I like to say George Miller's work gave us some good hints about how to build a semantic network, and didn't quite get it right because it integrated the science at the time, which was parts of speech, so you get massive duplication. But that's the way we're going to finish up. And let's see, negative use. What have I done? I've just hit something there. Let's go back. This is better. Negative use. Oh, I can't read it either. Avoidance of process. Oliver Selfridge. Oh, okay. So engineering follows science. So we've learned a lot about what we should do, and we've also learned a lot about what we shouldn't do. Oliver Selfridge and Marvin Minsky both came up with these models of agent-based technology. Let me just show you. So here's Society of Mind, if you can see that, from Minsky. And in that he's got all these examples, which are great examples, things that we have to do. But he tends to put the onus on, if you've got a problem to solve, you break that problem into multiple agents. So think of it as multiple intelligent things. And then those intelligent things work together. That's how Oliver Selfridge's pandemonium model worked. I don't really like that model because you're taking a complex problem and just making it harder by requiring more and more intelligences to work together. If you have a pattern matching model, then there's no intelligence as long as you can get the patterns stored correctly and work out how to control them, which is what we do with our NLU system. Right, so engineering approach. This is the last topic, and it's a pretty simple one. If you want to build a new industry, a good way to do that is to use the approach that has been used to build other industries. So I looked at the IBM implementation of System 360 back in the 1960s, and they were very clever to notice that if you've got one of their IT systems and you've built software and you've had 2,000 people writing your software and it works, when they release a new machine, if the software keeps working, then you've protected their investment. So that type of investment protection is critical to build a new industry. Now there's two obvious points. Do I make them on the slide? So that's the backwards compatibility thing. But the two key points are, if you look at the deep learning systems today, people are tinkering, retraining, and that's a very expensive system to continue with. And if you want to then use that same system in another language, you're pretty much doing it again and again and again, depending on how many languages you want to support. I've done a deep dive video on the technical approach that we've taken for this NLU. And let me just show you what that looks like. It starts with a linguist documenting the particular problem that we're solving. We then add testers, and the testers make sure that each of the examples that the linguist has put in is being correctly broken down and that the tests are passing. And then that becomes our regression source. And then the super knowledge graph I've written about separately, which is how do you take language independent information and store it in a lossless format so that you can then make this whole thing work for the long term. And when you think of it, why won't this system be working in 1,000 years' time? The more we get information into this meaning repository, the more accurate the generators into the target languages we care about, and obviously the recognition as well, the understanding generation. Why, what's a better model than that for the next 1,000 years or 1,000,000 years? Who knows? And here's just stepping through it. So linguists create the spec because they understand language, they understand how role and reference grammar works and the other semantics concepts they need. They write a specification. This is how we're going to test this particular thing. The types of things you can imagine testing, time frames. I want to go in 5 minutes, in 5 weeks, in 5 years, in a century. All of phrases of that nature can be documented, and we can implement them. And once they're passing, that will pass forever. I want to go for 10 minutes, for 10 months, for 10 years. So that's the duration. So all of those types of things might need a pattern added to the system, but however we implement it, once those tests are passing and we're getting the correct interpretation, they're going to keep working forever. Do you hope, here's the question, do you hope to eliminate something, possible sources of native speaker bias through the regression process? So the regression process is testing our dictionary to interpretation. The next step, which is when we're storing things in the super knowledge graph and we're extracting this. So that's the context. So when you've had a discussion with someone, that's where that type of bias could come in. And because our system's not storing that as the interpretation, the system shouldn't be biased. So yeah, I don't know if you take the deep learning paradigm, they're basically taking elements of context that they don't understand, and that becomes the basis for your system. So one system has the built-in bias, and our system is simply working off what things mean. So we've got testers for the regression, then the fully tested system validates that there's our regression, and virtual assistants are using the new technology to control the conversation to the end. And there's our happy user interacting with the virtual assistant. Okay, so that wraps up the formal part of the presentation today. Are there questions? Okay, with regards to multimodal, multilingual approaches, could you explain what you would consider sufficient support for any given language? And could you briefly explain again what are the benefits of this? Oh, benefits of these implementations for translation services, etc. Okay, so with regards, well, the first part of the question, the multimodal, multilingual, sufficient support, I think the step one is work on a particular use case and get the next generation systems up and running. As those systems are deployed, we simply want to consolidate into one repository the dictionary information that's being used. So that'll be the specific words and phrases, but also the first 4,000 words in particular that make the language work effectively. And provided we can keep different types of use cases going, I think then we've got the virtuous circle going well. I think I said that okay this time. So that's probably the first point. There was a second part to the question. So for things like translation services, we're in the perfect position now for taking the conversion from language to meaning and then back to a language. It's a perfect state to test those pairs and make sure that we're generating the same thing that a native speaker from the first language would expect to be the meaning of the target language. And that way we're using a low risk natural type of interaction for people learning a language in order to then build up our production systems for these next generation systems, and then setting the framework for the single meaning repository or the meaning repository concept where people start publishing their own information in meaning format. What are the best initial use cases for next-gen NLU? Is it easy to apply to any use case? I like to think of it this way, that RTW tickets was an exceedingly hard problem to solve. And we've shown other people, hey, this is a big design, and they say, oh yeah, but that was an easy problem to solve. Well, no, it wasn't. But the approach makes it an easy problem to solve. I think that the types of things that we should focus on initially, commercially at least, are those types of problems where there's a high payoff, things that aren't working that with a bit of analysis and implementing next-gen NLU will work better. The types of things that would take longer are things that people take longer to learn. So medical applications, legal applications, where the phraseology of a sentence may radically change the interpretation. So you don't really want to start off with those. You want to start off with the things that make the language better, make the system better, and then lead to the more complex examples that people have to learn over years anyway. All right. Well, I think we're getting to the end of it. And thank you to the moderator, Beth Carey, today for posting those helpful messages. Much appreciated, because I have enough trouble remembering what I'm going to say, let alone follow what's going on the screen. Following what's going on the screen. So, thanks everyone for joining us today, and see you again next time. Bye for now.